now we have to show money that we don't want to upgrade. And they didn't know how to do it, so it was just throwing people into.
Yeah, so
I don't
know what's
the main driver.
Yeah.
Which is good.
Actually, there's another thing is after the company or after like they call it this right after the halfway narrow massive greenway to go with the air.
Okay. Which means for 7 minutes, I will come back to for the database design.
That's really one. I think you're the only Yeah, 1917.
Which is. Yeah. I'm not saying.
Oh, you've already.
I changed it on.
Yeah, like this was first second.
Yes, like I downloaded.
Yeah, but in.
Then I talked
Is about how important. It's a war in the.
Yeah, that's-
18 That's what they call the lost generation.
Because you have to restart
You
it.
know, like.
And it accomplished absolutely nothing.
Control
Yeah,
Z.
I imagine time for a year to end in nothing. It's just sad.
That's what you just.
Or two, at least it did something.
It did.
And that's worth me ever having more likely to get a big major war.
The deal was, we weren't supposed to have.
Yeah. It's been going on like 80 years so far.
You don't have to.
Speaks more against the common resources.
Now,
Think about moving up the moon.
Or remember the giant, like the giant, or the space stations, basically, or something.
The Austin Towers. I guess are you seriously talking about going up there? Let's see. Would you disagree? You just. Like. The tides change, but you know.
Sometimes I can see.
That's cool.
It's a keep it back.
Yeah. And then I don't think that's.
Under 1990s.
Yeah, I'm from all that.
Yeah, because it encouraged this.
It is a monster in Jack.
I got a monster jacket too. It's like a flight jacket, but like has all the polymer. Yeah.
Because the engines.
That's my favorite jacket. Because they're all those.
Same guy.
There's never.
Sorry. That's why.
Because it's pilot is.
Yeah. They're good. Oh, once a year in Texas. Yeah. You're lucky.
Oh, the wrong place. I love it. Like, you can that picture of the computer, but you, when you walk outside, you were like, no way, like you're drowsing. That first breath almost like sears your lungs. Have you ever seen? So, if that is, are you familiar with? We thankfully haven't looked quite the same now. That's what I got. When I first got it. That is. I looked like a big girl.
Okay. So right now we start our system design. So before we talk about the UI design, so for UI design it's really hard to teach, and sometimes like we do have some like flow or standard for design and UI. So like what's the UX about the buttons? In the video I do introduce one for presenting for your system. Sometimes we can use called the if you're using Adobe, we have the InDesign. It's popular, it's called the Figma. So anybody know what's Figma? Have you heard about Figma? Maybe for the okay. So Figma is the really Okay, Figma is right here. Lots of designer they use Figma for the like designing the interface, also the flow. So like let's say start from the launching page, and then maybe they have some buttons. Maybe you have a table view, and then click on the buttons. So you can define all the everything, and then you can put the link. So you can say, okay, if I click on this button, then I will redirect to next page. So all this, so you can create all the flow. So this one sometimes is like for demonstration, showing your layout of your design. Okay, and right now Figma they do have an AI. So after you create all this interface, it can generate a source code. So even you can turn your UI design to an actual program. Okay. Of course, you can try maybe when you need to use it, then you need to pay for it or subscribe. But for create a UI, you are feel free to use. But for sure, because you are using student account, I think you can use the Adobe InDesign. You can download it and try to create. So it's a similar function. So either one of it, just for your reference. Okay. And today we talk about how about design the database. So for the database, as I going, so you know why now it's a really important. Actually, it's a component for system design. Because when we design the UI, and then before we discuss what's about the like the flow, like how can we send the data to the API server, we check it. So for nowadays, we need to store all the information. So the database that design we will transfer the domain model or class diagram into a detailed database model for the system. Okay. So we can use it to implement and then interact with the database. So we sometimes call it DB. So database is an integrated collection of stored data and then centralized, managed and controlled. And then we have the DBMS. So it's the managed system. So it's a software component to manage the control of one or more database. If we are using MySQL, then we can use the workbench, or we can use the command directly. If you are using like Oracle, we do have the database, and even for the like nowadays, because for this lecture it's pretty like I say sometimes old school. So right now we maybe consider also NoSQL. Like in our lab time, we talk about maybe Spotify, maybe Uber. So we actually combine two different type of database: the relational database, MySQL, and also the NoSQL together. So it depends on the service we are providing. Okay. So but the idea is the same. Also the schema, so it's the components to contain the descriptive information of the data we store in the physical. So all the information definition, also the SQL, the SQL. So it's the standard query language to access and update the data. Okay, we call it CRUD, CRUD. So we also able to like create and read, update, and delete the records. Okay, so when we mention all these things, the components right here, actual database, we have different like application domain data, schema data. And then we have the system itself, the DBMS. We have a API SQL processor, and then direct SQL processor or memory interface. And most of the time when we implement a system, we are not directly interact with the database system, but we interact through the API server, right? Not yet.
Yeah.
Okay, let me see.
I don't see week 10.
Okay, I forgot. Sorry about that. Okay, let me do it right now. Make quickly. Let me week 10 one. Let me, I think this week 10. Okay. Okay. Okay, you should able to see right now. Okay. So you can download, and most time we have a like application program that connect to the database, or sometimes we have direct query user or database administrator to connect this. If we have application like hosting on the server, maybe we will directly connect to the server. But sometimes maybe we will send all the requests to the API server, like for a better system. So if you look at the diagram we have, we always like sending from an application to the API server, sending the request. And then the API server will, based on the requests, based on our need, will connect to the maybe if we're connect to the RDMS, then let's say MySQL, and then we send in a query to retrieve data and return it back. Okay. It's a better habit also because nowadays, because we are implement everything in teams. So maybe there's some teams that are working on the database, and there's a team working on the API server, and then there should be a team working on the user interface or like application. Okay, maybe desktop website or mobile, maybe the application. So when different teams working together, it's impossible that for the cell phone team that I will try to, if I want to get the data, let me connect to the database system directly. So it's not a good practice. Also for security. So everyone have their own access to the database. That means that, okay, how can we prevent the access? Like I want to update the data, you want to read it. So who have the right? And also like maybe I read the outdated data. So for prevention, we always try to implement an API server that help us to handle all these requests. Okay. And if you did learn something about database, that's like we call for the memory, just like revision. So for the schema, so it will organization individual store data items to high level groups, just like table and then association among the tables or classes. And then we have details of physical data, store organizations, including the types, length, location, all these things. Also, we have the access and content control. So allow the values of specific data items or the value that dependence among the multiple data items. So they will list the user allowed to read or update the data item. So here things. And characteristics of the DBMS. So it is simultaneously accessed by many users and many applications. Sometimes you can define the pool, like maximum connection too. For the API server, sometimes you can set the maximum connection. Then if there are too many, they can wait in the queue. So depends on the resources of computer or the processing power bandwidth. So they allow direct access to the data with the data interface. So the interface that we say, okay, maybe the API or the MySQL interface. So they're uniform and consistent access. So make sure the integration and distribution of data across multiple servers. But in why not if for some like mobile apps they're serving globally, maybe Uber, the Spotify, like example, or more than that, maybe we have multiple servers, and then we have also different data servers, data center, like they're hosting in different like physical location. Okay, so maybe they have got the leader server, data server, and then they have some others. Okay. And all these, maybe they will doing some like duplicate, overlap for backup. So how can we make sure like the data like across multiple servers? But of course, like in your project, like for study design, then maybe you don't have to make it too complicated. And for the design, so when we need to think about it, so the database integrates within the existing technology architecture. And also, what is the existing like technology architecture? So hardware and network. So it's for single desktop, or like are you sharing the database? So how can you access to the LAN? Or it's a large database. So multiple server have a single data farm, and then maybe a very large. So they will have multiple server across multiple data farm. Okay, across each other's. Okay. And just like more question, you have to ask like, how does the database design integrate with those like project plan? And then we have the waterfall development. So it's one of the development plan, how can we design, implement the database? Okay, so later we will talk about what's waterfall. Okay, just but you can think about what's water from top to bottom. Okay, and interactive development. So database is like fundamental, and then early iteration, I need to focus on data, and then key portions of database and interactive development will be important to consider the database impacts of other subsystems. And we need to think like who is involved in the database design. Maybe we have the data administrator, and then maybe database developer when you think. And for the DA, the administrator, maybe like in charge the structure integrity of the data. So we need to know like what's the data standards, like data use and data quality. So what data rules. So you need to know. Lots of definition. You need to know, but I won't ask you what's the definition. So, but you need to have a concept like how everything works together. And then we have the database administrator. So you see the difference. One is called a data administrator, one is the database administrator. So he's in charge of the safety and operation of the database. Okay. So right here, so we have called a DA and then DBA. So even you look at the definitions, then what's the actual difference between these two positions? Any idea? What's the data administrator? What's the database administrator? So here's like we talk about the data standard use and quality. Like the naming, definition, data typing. And then for the database, is maybe we have the metadata like define all the data like, but for the database administrator, that means really like for the management, for the database, the system itself. Okay. Data can be, you can define it with the list content, but for this, you have to interact with the software. So you also need to like protect the database and data, and then also the high performance level. Okay, and then back up the data and then define the recovery procedures. That's what the database administrator needs to do. So right here, so you will see on top the database administrator, we're taking care more. So we say the environment, security, protection, performance, recovery. And inside the application, we have the actual data. So it's more about the standards, ownership, quality. So will be the data administrator doing. Okay, and then we talk about the relational database. So so is RDMS. So it's a relational database management system. So it will be saying that a DBMS like organize the data in table. So it's a slight difference right here with all the R. And then tables is a two-dimensional data structure. So we have a column, that means the attribute, or we call the name. So for the single row will be one single record. Okay, so for name. And then we have the attributes, so one vertical groups, and the attribute values that inside the table, one cell. Okay. And relational, we have the key. So it's an attributes or set of attribute. So if you learn, we have called a primary key, candidate key. Those like when we draw the diagram. So you need to recognize for the, if you're forming the primary key, we have using several attributes together to form the primary key. So that's why we can say we have a set of attributes. Okay. So for this one, and we have the foreign key, and sometimes we will do the indexing. Okay, maybe using the like increase the searching speed, query speed. So right here you will see here's all the attributes, and then each row will be all the records. Okay, and when we use the database, so you will know like what's the first normal form, second normal form, all this like SQL. Okay, so right here, and mainly because for the diagram, so associate between two classes. So we have this one is more like this class diagram. So you have a table name or entity name, and then what are the attributes or the field inside the columns. and then showing the relationship. So it's like one to many. And if you remember the cardinality or the relation, so it is like one, maybe one to one, one to many, or minimum is 0. So if I look at the numbers right here, I know what's their actual relationship and then their cardinality. And also the association with like they have a foreign key. So the key is right here. So associate for 2 tables. And then when we try to design the relational database, we will create a table for each class and then try to choose a primary key. So at this one, and then for actual good habit, we always try to create called the, for naming, I will put the table name with the ID. So if you say, if we create a user account, maybe we say create a user ID, and
It's not me. It's Megan.
okay, it's the, okay, it's taking off right now. It's ready.
This may take 4 minutes and then I see HP bios that day. Never mind.
Okay,
Yes,
so
that's me. Oh, that's you. This thing thought it was me.
and then we try to add the foreign key to represent like one or many association, and then create the tables. I think all the steps, but I want to ask, anybody don't know how to create the tables or drawing? Well, I'm telling all the steps, so don't know how to create all these database. Or like when you're learning database, I think you did have some project or exercise to create the tables, right? Okay. So I just go through. I just reading the steps. Okay. So define the referential integrity constraint and evaluate the schema quality and make necessary improvement. And then you need to choose the appropriate data type. So this is what you need to do to actually implement the for your project, maybe you need to combine both. I kind of recommend, because if you really want to working or fit to nowadays requirement, you need to know both relational database and the NoSQL. So you need to like knowing how to implement both 2 types of database. Okay. And then taking the example, the RMO, this one is like for the whole PowerPoint like lecture from the first one until now. So it's a cases. Also, it's like using the classes right here. So there are promotions, product comments, inventory items. You know, once you create the database using the MySQL, actually you can generate the relational diagrams. So do you know that? Have you ever used the MySQL? This one. Have you heard about when you implement, because you're using your local, you did implement locally, right? Using the MySQL bench,
Yeah, the workbench.
the workbench. Okay. So also the workbench, you can generate the diagram. Have you ever tried to generate the diagram? So once you create all the database, then you are able to generate them. Yeah, so yeah, once you build up like when you set the primary key and foreign key connected, then you will generate, you are able to generate the diagram. Yes. So when you implement, you don't have to draw the of course, in the system design, like first step, maybe you have to draw it by yourself. Like of course, you cannot like reverse the step. Let's say let me implement the yeah, and then initial set of tables, like it's an example right here, and more examples. Okay. Well, I believe like maybe you need to have some like practical, but of course we just like go through more like definitions and lecture, and then remember to add the primary key attributes to your class. And also when we have many to many relationship like the classes, then remember to sometimes they add one more like intermediate class or intermediate table for transaction. Because we barely have directly implement many-to-many tables. To know this one, what's the definition was here? Many to many. Or like, do you know what I'm talking about this one?
Yeah, many and many. Yeah, many objects, associate with many objects.
Mhm. So if I say for actual implementation, trial, if I have two tables, and when you really implement, we never like putting two tables as a many to many. If I have two tables, maybe I call it like user and orders. Oh, it's not that good. Maybe orders and products. Okay, products is okay. Okay. For the products, we can belong to multiple orders, right? And orders can have contain multiple products, right? Okay, so this one is the many to many relationship. Okay, and for the ER diagram, of course we can keep it in this way, like many to many, showing the relationship. But when we actually implement, create a table, so are we just like create a table called product and one table called order? For this one, how can we implement actual table? Is that exist? Okay. Okay, so I would like to see just give you some exercise. I think just listening the definition is pretty boring. Okay, so give you the okay. So why not if I have a table is called the order and then one table is called order, how can I really implement in your MySQL, like maybe as a RDMS? You can just put at three attributes. Remember at the primary key and then maybe some attribute names. And then why not in this moment, it is many to many relationship. Okay, so if it's the EL diagram, it's the many to many. So for the orders, we have okay, with the cardinality, can anybody answer the question? Okay, so what should I put? If I want to put a notation like this. What's the cardinality? Is it too small? Is it better? Okay. If why not have a product and then the order. So why not this one just the ER diagram? So okay. Anybody? Can you answer or like I give you some time, like few minutes, think about it and then tell me the answer of this one. Okay, I have a question mark right here. So this one actually called a cardinality. Like first is showing the relationship is like, is it one to many or many to many or one to one relationship? Also cardinality is like tell me the range. So we have the one to many and one to one and many to many, right? The relationship and then cardinality is telling. So right here, minimum may be 0 or 1, and maximum is 1 or many. So this one, if you're keeping the numbers like this, they are not okay. So it is a one to one relationship, is one to many or many to many. Okay, so you can do it like this. If a maximum, and then I mean this one, the relationship is many to many relationship, but it can be nothing. Let me say the items is it possible that I didn't contain anything in this table? Okay, but if I put in 1, that means at least 1. Okay,
You have at least one product. There could be no orders. In which case nothing's happening.
okay,
You could have many orders. One product, or you have many orders or one for many products.
okay, we can. So answer the one. Okay, so right here, what should I put? 1? Well, no, this one is the maximum.
Oh. Many.
Many? Okay. So that means like for the orders, we have many products, right? Is it possible? Okay. Then how about design? Many. Okay. So right now it's a many to many relationship. Okay. So for the products, I can contain inside many orders, right? And then for the order, I have multiple products. Okay, works. Okay. Cardinality minimum. What should I put?
Minimum.
Zero, you don't have to have any products in the order. If the order is first created, then you don't necessarily have any products in it.
Okay, so 0, 0. Oh, I agree. Yeah.
I think for an order, you're already having stuff in your cart.
Mhm.
I'm gonna say one, because like,
Yeah,
not an order if you don't order everything.
yeah, it's not working.
So 0 or 1. So you see. So that means like you don't have to really have an order. So of course, depends on assumption, but most of it, it maybe makes sense that is it possible that I have a product, but I never sell it,
Yeah, that's fine.
or that it never being sold? Is it possible?
Yes, I'm sure there's something on Amazon that has never been found.
Yeah. So actually it should be. So you need to think about this. Like if you do have a assumption, you say, okay, at least like all the products, depends on maybe if I am a factory or something, okay, if I'm produce a product, it should be have an order. Then it should be one. Because like if I make this product, at least I have one order, then I will produce this product. Okay. But maybe I'm a company that doing trading, maybe I'll get multiple products, but really depends on the order, right? So I just prepare and leave it over there, or it's a store over there. I have so many things. Maybe I have a pen, it's never been sold, like nobody want to buy this pen. So it will be always 0. Okay. But always like depends on the situation. But if we put in the condition is that right now I just like maybe regular, maybe using online store, or maybe Amazon. So it's possible I put the I post the product on the Amazon and then nobody buy it, right? So it's possible that there's an order, there's a product. It's possible that it doesn't like being so like contain inside the order. Then how about design?
Well, no order will always have at least one product because it's not an order if you don't have anything.
Okay. Okay. Then the second question is like, is the location is correct? Is it putting in this way? Or should I do it like this or like this?
I thought we were originally, the way we notated it was like a series of arrows,
Yeah.
like an additional series of arrows.
You can do it that way, but you just usually put it on the.
Yeah, so actually we are not like or like we are not using the arrow. Let me see. I want to remove the arrow. No. Okay, let me see. No. No. Want to create a line.
Let's see. Let's see the symbol
Too
right
small.
where we talk about.
Okay, just a line. Okay. Okay. Suppose it's just like this. Okay. And so is it okay? Version 1 is this one, and then version 2 will be okay. And A or B. Okay, so he's testing your understanding. A or B. B. Okay. So how can you read it? So if using B.
So if you have an order, you know, you could add it.
Okay. So are you all agree is B? or okay, B. Okay, yes, it's B. Okay, yeah. So really be careful because some of them will mix up. So that's why I try to confuse it. And for the many-to-many relationship is easy, or sometimes like maybe you need to think, especially for this condition is like it's many-to-many. Both two sides same. But one thing is like for the catenarity, like the minimum. Okay. So when we read it, okay, for the order, so we need to look for the product. So for the order, at least we should have a one product in your order, right? Suppose that you say, is it possible that I try to add the order without any items? It's impossible. So that's why it should be at this one. Okay. Otherwise, you didn't really purchase anything. Then how should we create the order? And then, but for the product, is it possible it doesn't contain in the order? So maybe I never like nobody buying this item. Okay. So it's B. Okay. So the follow-up question. So we already, let me delete this one. When we actually implement, so because this one is the many-to-many relationship, it's okay. For the ER diagram, we can showing because it's showing the relationship between the entities. Okay, but when we actually really implement, if we follow this structure and then try to create the two tables, product and order, then how can we implement or how can we modify? That's the question.
Would you use a third table as a joiner table?
Then how can we using the third table?
It would, if the order needed 5 different products, then you'd have another table and it would have per product, let's say the order ID and the product ID. And so then when you go and search for every order, for all the products in the order, you would search the joiner table. And in the joiner table, you just search by the order ID and you get all of the products.
Okay. But if I want to see the drawing diagram, okay, let you have an exercise. Okay, so for the I would create maybe I put it under. Okay, you can using draw. So based on the question for this one, let me put it looks better. Let me put right here, and then export it. So based on this one, create actual implementation for your for the class. Okay, then how can you create the diagram and then put the correct relationship and also the catenarity. Okay, so let me output it, export as the PNG. Let me put it okay, I create assignment. So you can just answer you can join and then send upload it. Let me create. So I'll give you some time for you. Okay. 10 minutes, 15 minutes. Okay. Or you have some class exercise and then you can download it. And let me post it. Computer. Okay. Manage relationship. So I give you some exercise. Put any. So draw diagram. Correct. Correct. Many to many. That's- And then I will visible. Just like for your revision, let me show you this one. Okay. Then do you get what you need to do? Yeah. So yeah. So right now, what you're looking in this one is I would say it's more like it's just the ER diagram. So the relationship is a many to many. But when you really create a class, then you are not, suppose we are not creating two tables. Then already telling we try to create a new table. Then how can we do that? And that's what you need to do. So you maybe need to add some, let's say the primary key, maybe you can add 2 to 3 attributes to represent the content. The hint is you need to create one more table. So if you are also joining online, then you can spend some time and do it. If you're able to draw these things, then you should familiar of like what is the integrity, referential key, all the constraints. And also we need to do the normalization. If you know the first normal form, second normal form, and third normal form. So actually more likely if you have a many-to-many relationship, then we need to go through like third normal form to change to 3 tables. So when you're doing that, just reading something. So we have the first normal form, we like making all the record in single row. Dependency. If anybody, if you finish, I would like to, you might just show me the solution.
Yeah, so you have to have some kind of way to represent multiple products, so. So you think about like the. Alright, so. Oh, so like this is there. Well, you know, yeah, you could, yeah, yeah.
I can share that. But say for quantity, something quantity is not really good to sometimes. Other thing is something I have a favorite book. If you are the one look at this thing.
Yeah.
They do example, what's this table doing?
I'm trying to figure out what's doing.
Sometimes, okay, one option of, okay, for this one, maybe I would say it's a transaction. Or if we do that from many, and then we try to have two tables that need to connect, we always say, it's common order, or you can add on the top. Then you go bring back to tables together. Okay, you know, design the relationship between two tables. So sometimes when I look at this, okay, then I know, okay, this table is set based on like those two tables, because they have a very tight relationship. So I need to create one information translation table. And for big back some of them they're using and finally they're using two attributes to find the primary key. Or actually most of the time I use it for the ID. So I always create a new primary key. As I do have this one. Instead of using keys and create one. Is the difference between lecture and practice. In the like when we implement database, I will add one more key instead of using two lectures in the form.
Yeah.
And so it would be better. And then we will say it's like index and then maybe auto. Then for the primary key, we don't have to each anything. So when you try to search the we don't touch the primary key. So we don't know if they like implement one. That's how it like everything works. But
Okay. So isosum is okay.
for the okay. Or could you add some like primary key? Maybe add like two to three attributes.
Oh, I see what's going on.
Okay. Also, I would because why not you should like T-shape? So if you show the T-shape, okay, so are they joining together? Yeah, that was example. Yes, anyway, it's one to many, so. And for the sequence, we always say the left one should be the minimum, and when the right side will be the maximum. So it's always one to many, one.
Oh.
Yeah. Yeah. Because this one is called a cardinal.
So no.
If you join in the so may be here, because for ER diagram, we don't have to, it's not required to break down to one to many, like. We can keep the many to many, so, but when we draw the class diagram, then we have to
Okay.
create another one, yeah. Because for the ER diagram, we just show the relationship for like tables, like, yeah, for entity. Yeah. So you mean like just add. Yeah, yes, actually, so, yeah. You if you're able to do this, I feel like you will be like. So we have problems. Okay. There's no.
Middle, like a straight line.
There shouldn't be something connecting.
You can use analytics.
Okay, I don't know if you're supposed to do that one.
You use different. At least like if you can make it correct, that means I have your. Also try to add some attributes. And on this one, okay. I think it's very good. Yeah, you can look out drawing. So you can say, because right now you already will not able to get, so you should like show it. So when we have enough experience, but also. Yeah, okay. So those are.
No, I wasn't.
So.
I don't really have it.
I can look at this one, so why not you're missing your second shot?
I didn't go further.
No, you agree?
I never go to.
So you need to copy like that. And then. Everyone's like.
But they did that. Like.
Yeah.
It all goes to the same rate.
Usually I was wondering, the kids were all in my. Really, I had that video like 4th grade, like 6th grade, showed the kid. Video like. And I had, they could, it's really not allowed, I told her to pull off, so everyone was just like, do because we're like pulling that thing. And it's like, so you see everyone had like, it's so part of the thing, it's like, yeah. Of course, we're being sure to pay for that's like. If for chunk, and then maybe it's not, that's not. Yeah, I can. Also that card, yeah. So like, what's the meaning? Yeah, exactly. It's sad, it's so hard to live, like, so putting such unrealistic.
But he said you don't need the one amendment. I realize it may not.
Well, you just need,
You said just give me some attributes. I just, I need that additional stuff. Yeah, actually, it's like section off.
It's set in so as a task exercise.
and what you forms, like this, it's like one mini. Is that question? So how should I connect them? How do you connect it? Yeah. Just join the line. Can you see the comment? Yes. And then keep it and put. See the line. Oh. Like on the phone that because sometimes we. You already can. No, I think. So why here you say, okay, for that, for that.
It's closer to what you're looking for.
Yeah.
This closer to what you're,
the, okay, so this one is the cast iron. So, like, for the ER diagram.
If we draw the ER diagram, I will put the attributes like on the top, like this. Oops, it's pretty big. Okay, so I'll put the attribute, but this time, for the ER diagram, we don't have to transform the many to many. But if I ask him to draw the like transform it, then it should be a class diagram. So what should the class diagram look like? That's what you did before. So class diagram, yeah, relationship. So you need to like use the table in this format. Like have a table name, primary key, and then with them attributes. Yes. Okay. I know it's like confusing, but really you need to do it. And for system design, you need to draw lots of that. Okay, and then if you draw the connection for the field, then you need to put that relationship. And then
That or like this?
Yeah.
Like that.
yeah, so this
Okay.
one is the ER diagram.
This is ER, that
Yeah.
one's class.
Class, yeah.
Gotcha.
So that's why I say for ER, you don't have to put the intermediate string. Because you are okay to keep the many to many relationship.
Right.
Yeah. But
Okay.
if I say, okay, please draw the class diagram, then you need to change the term from the many to many to many to
Thank you.
so, yeah, this one, okay. Okay, yeah, okay, so that they explain there was the relationship. Yeah. Okay, so for products, why is one to many? Can you tell me?
Because an order can have one order can have many products. You know, so you have to do one second.
Okay, our assumption, okay. Okay, so right here, like, for the orders, we have many products, but at least we should have one product. Okay, yeah, so okay, but how about from this side, for products? So at least like for the products, at least should be in one product. Or many. So, based on what you're talking, is it possible that the product in doesn't contain any order? Yeah. That means that this product name is nobody. Yeah. Okay. So is it possible that it should be zero, yes.
But you can't have an order.
Yeah. Sometimes like we need to put assumption, like for system design, for reality, it's really possible, yes. I said we have two situations. Let's say I'm the manufacturer. I will produce my product based on my order, then yes, I always have one. That means like if I'm order and I produce it. Yeah, if I'm like I'm online store, I trading, and maybe I have multiple products. Let's say, yeah, so maybe for general online store, they never sell this. Yeah, so it's many. Okay, no, how about this?
It has to be one of those, right? Because there can be many orders in one place. Yeah.
Yeah, for the relationship, using no for the dynamic. Okay, so this one is still the same. It's still many to many. If like the relationship, they will change. So if you looking at this one, saying for the order, and they have multiple, like place the order. And or they can only one.
I don't know.
And
Because I would think there would be, it'd only be one to one. Because you can't place an order without one.
You have to have one product for your own place in order, but one order can purchase many products.
Yeah, but only have that. One order would be like the joiner do you have?
Well, then you would have multiple products.
yeah, okay.
You have one order number, you would have multiple product IDs. I mean, your order has one.
Okay,
No, that part I understand.
Okay.
So if I'm looking at the diagram, inside the product where it says order, the bottom side is the one I understand that how an order of product have no orders. And I understand those. The order itself. Or one order.
It's slightly tricky and should I just put it in when he, okay, and then just. No,
It's a place order can not have an order.
So we just.
This part. Place order can have zero, and then you said. Place an order, you can do.
And you need to add everything.
All right, thank you.
So I know some of you are like pretty okay to go to this step, so I need to remove the relationship and add more extra tables, right? And then connect to this one. Connect to this one. Let me remove the head. Okay. Okay, so once I have a one to many and zero to one. So let's see. Okay, so when you create one more extra table, so make sure, because right now we are not looking at these two tables anymore, but like product with the, maybe I say intermediate, so we call the order product. Okay, like this. Record maybe. Okay, and then I have a ID called the order for the ID. Let's say like this. Okay. So the next question I think you ask. Okay. So right here, stay on a condition. So for order, at least we should have one product contain, and then we have multiple products. And for the products, it may be not contained inside the product record because we didn't sell this product when nobody purchased it. But also we can access right here many. So you can see multiple product ID right here. And then what's the next question is, how about this side? Okay, so I leave this question empty for you and then really. Let me look at yours before I tell you. For this one, we working, okay. One thing is like when you confuse. For the cardinality, the left-hand side is the minimum and right-hand side is the maximum. So the form is always like this, okay? But when we read it, we can see, okay, if I put the relationship like this, okay, this is not the correct answer. But if I putting in this format, so okay, let's say like this. So it's one to many or many to one relationship. And with the minimum is zero and minimum is zero. Okay. So for the cardinality, the relationship should be minimum and maximum. So the format should be like this. And maximum. Okay. But when you read it, you're able to tell based on the maximum, then you know, okay, it's a many to many one. So what's your relationship for this?
Mine, I did, certain product, mine was with zero to one. Like, I basically,
Okay.
I inverted, the response we had to zero, for the one to many, to zero to one. But zero to many, they're initially here, considering this two.
Okay.
And with that, like this. No, when I have zeros as one of the product, it's not necessarily every product.
So if I looking right here, so if I convert this by say for the products, I can like as long as I'm going to do any product right here, okay, so zero or many, or zero correct. And for the products, I minimum zero, so means that I as long as I need zero. And for one is like maximum, I only have one product.
I really don't remember.
And then this side, okay, yeah, you can put it, I just change it.
Come on the dating installment.
Yeah.
Okay. So right now, okay, I will say finish like first, right now is that we can so one. So you need to put type in there, like, on the left hand side, if you talk about.
I don't want to think about it.
Yes, yeah, the formation is the range. Okay, you see the one color of with many, just so that is this. Oh, you can use it stuff. Okay, you got like for different. Like that, like they have different style, so I can understand, so it's okay, so if using the style of many, it's okay, but that one is only showing the simple relation. But if I ask him to give me cardinality, so cardinality is the range. So right now you will see, if I replace it,
If I replace this one, because I don't mind if you're using the star or many, it's okay. So to me, I will accept it. So it's okay. It means same. But for this one, it's like called cardinality. That means you should give me a format minimum and maximum. Okay, yeah. So
for this one, what is the minimum? What's the maximum? Okay, so do the same. Go back to this one.
Yeah.
So can you explain?
So you gotta get at least one product.
If I have a design, so
Yeah.
the difference between the product and products. For the products, I may not insist in the transaction of the packaging. Product may be in the terminal, but in maximum, I will have one. It means this product only can sell once. Yes.
Yeah, I mean, that's what I had.
That's one of the.
So you need to change this up. This one after, so you have right, I need to cover it. Okay, so when I read it, it's like product and your order.
Yeah.
So I'm not looking this one. So when I.
Okay, yes, that'd be one thing.
Yeah, so it's. What is it?
Yeah, because the product is, you could have multiple orders, because right, this is like combined, you could have an order of like celery, right? Three different people, with three different orders of celery. And it's still.
How about for here? If you put one command, that means. Yes, zero, that means. This product may be not, like I didn't sell this one. So the right hand side should be zero to many, so that is the answer. It's right here, it's right here.
I did too, but like, there's a
This
difference.
side, how about this one?
Yeah.
So then like, okay, when okay,
No, on one.
for the order, how many for the?
Your bond is here.
So, one of zero.
Yeah.
Then at least one product or?
At least one.
Yes, at least one, okay. How about maximum? Maximum is one.
Yeah, I mean, well, I mean, like, my middle table can only have one product.
Is the for relationships, like, do you think the product at least just? Do they, okay.
The more I think about it.
They can confuse them with the concepts. So, okay, so right here, so let me repeat. Let me explain one more time. Okay, so I think it's the end of the class, but I'll let you to finish. And if you are confused about the relationship and ask like, I'll leave you to finish this part, the right hand side. Okay, and maybe I'll come back and answer. So if I need to look at which one should I look at? If I'm looking for the product, for relationship right here, for the
for my order, should I have at least one product? Yes, right. Okay, so here will be one. Then can I contain multiple products in my order? Yes, so I put many. Okay. Then you're confused. How can I do it? Yes, I can have like product ID right here, right? So I have many, like my product ID can appear like so many times. Okay, it can exist so many times right here, right? I can duplicate many times. But if I went out this time, I cover this one and look at this part. For products, is it possible that I doesn't like exist in this order? Yes, because it's possible that no customer purchase it, right? So it can be 0. But is it possible that I will appear like so many times? Okay. It's a question like, because like, but if you say yes, then I have a question I need to ask. Then it becomes a one to many and then also many to many. Yeah, so multiple things in table. How to clear? If you look at the row, it's say for only one product, right? So this one, it should be, that's why we always only have one. Okay, so for the orders, we only have one product, always only one. There should be one product and maximum only one. You are not putting multiple, okay? So this one is one. Minimum one, maximum one. And then, but for the products right here, for the orders, like if you're looking for it, you may never able to find the product ID right here. And you may be able to find multiple product ID in this table. Okay, so it's clear right now. So on the left-hand side will be like this. So it's one to many. So we don't have to change it. Then your follow-up question is that how can we change this one? Imagine it. Okay. Do we get the idea? So when from the record and I search it, so I always able to find only one product ID right here. And there should be one product ID because I should have a one product purchased. Okay. Now how about the order? I'll give you a question to let you think about it. There's okay, yeah. So when you implement, like if you still able to see many to many relationship, let's say like this, then that's incorrect. The reason why, because we try to change the one to many. No, we are trying to change the many to many relationship and then try to create one more extra table, right? So we try to bring the many to here. So the relationship to help you like easy to understand, the many always contain in here. So the M always exists in like putting next to the intermediate table, okay? And then we can change it to 1. Then the next question is that is it possible that I have a transaction or place an order but without any like order information? No. So we should at least to find at least one record, right? But how about the order? Is it possible that I don't have any product record? It's impossible, right? So at least we should have one. So here's the answer. So for all the products, like let's say for the record, I should belongs to one order. And I should have at least one order and in maximum also just one order, right? I won't have a record, it belongs to different order. So it's one. But for the order, maybe I can have multiple record because I have at least one item. If I multiple item, then you will see my order ID we repeat so many times. So let me just draw a table so we can finish our task. So for the information, if I have for the order and products ID, so maybe one, and then I have an order ID, and then the product ID. And 1, 2, 3, so it's the ID, and then maybe I have an order ID. So maybe order ID 1, 2, and then for the order ID, maybe I have product 3, 4, and this one is 3. So you see, I can have duplicate order ID, but also for order ID, I can have a duplicate. But for the order ID, I always should exist only one, match to one. So order ID here, like for the order, I only have one order ID. And then for the product, I also have only one product ID. Okay, so you won't, or you never able to see two product ID is same. Otherwise, it won't be a same product. Okay, so got you. Good. And you can finish and submit. Okay. Okay. Yeah, you can submit. It's okay. Okay. Thank you.